For the last example in this section, we're asked to integrate from 1/12 to 1/4 2 dt over the square root of t plus 4t times the square root of t, which is a mouthful. This case, I'm actually not going to use the trig substitutions like I have with the other examples in this section. Here I'm going to start out by doing a u substitution right off the bat, and then we're going to use a formula from the integral tables to actually get us to the answer. So let me start out here by letting u equal the square root of t. And that means that u squared equals t. And if I were to take the derivative of this, I'd have 2u du equals dt. So with that bit of information, I'm going to go back up here and rewrite this. Note it is going to impact my upper and lower bounds here. Since u is equal to the square root of t, the square root of 1/4 is 1/2. And the square root of 1/12 is 1 over 2 times the square root of 3. So that's taken care of. Now let's go ahead and deal with everything else. 2 dt is going to be 2 times 2u du. In the denominator, I've got u plus 4u squared times u. So notice that all of my terms have a u. I can go ahead and factor those out. So I'm left with, let me go ahead and get my 1/2, my 1 over 2 to the square root of 3 written. I'm left with 4du over 1 plus 4u squared. Now, we're going to end up using a formula from the integration tables, and I'm going to kind of get it into form. In the formula, in the denominator, we've got a number squared, which in our case is going to be a 1 squared. And instead of 4u squared, I'm going to write this as 2u quantity squared. In the numerator, I need to have the derivative of this. The derivative of 2u is going to be 2 du. Well, I have a 4 du currently in the numerator. I only need 2, so the other 2 can go in front. Once I have it in this form, I'm going to use number 17 from the integral table. Okay, and again, this is the table that's in the Start Here module. You can look it up, but I'm using number 17. And it says that when I integrate this, I just get the inverse tangent of 2u. So let's see what we end up with. We're going to have the inverse tangent of 2 times 1/2, so it's the inverse tangent of 1, minus the inverse tangent of 2 times 1 over 2 times the square root of 3. That's just 1 over the square root of 3. The inverse tangent of 1 is pi over 4. Inverse tangent of 1 over the square root of 3 is pi over 6. And if you find a common denominator and then subtract pi over 4 minus pi over 6, you're going to end up with pi over 12. So we have 2 times pi over 12 which would be 2 pi over 12 or pi over 6.